Check, 1, 2. Check, 1, 2. You hear me out there? Yeah? Testing, testing, testing. All right. Everybody smile. You guys all signed the photo waiver, right? You get to use your photo in perpetuity. All right, so my name's Tim Doherty. I'm an architect at Agilysys, working on the RGuest platform and products. It's my Twitter handle. You can find me on LinkedIn. My very seldomly updated blog. A little bit of background about me. I've been doing software engineering in one form or another since 1996. My early background was in desktop and server technologies. Went through the whole classic ASP, ASP.NET, PHP, server-side interpolated templates, things like that. I started using JavaScript in 1995 when it was dropped in Netscape Navigator 2. I was a college student at the time. I used it casually for the next 15 years, something like that, and thought I knew a reasonable amount about the language, and turns out I knew very little about it beyond surface syntax. Around 1997, I started using libraries like Prototype, Scriptaculous, jQuery, things like that. That kind of jQuery in particular, being an abstraction on top of the various browser inconsistencies, got me interested enough in JavaScript to actually take a deeper look. And then I moved into frameworks like Backbone, Knockout, and Ember, things like that. I'm an organizer for my local JavaScript meetup. I'm based in Santa Barbara, California. And I got promoted to architect in January of this year, which means I do less coding than I would like. I spend probably less than 50% of my time coding now, and it's not all JavaScript. You know, I have an emphasis on the front end, but I do lots of stuff with Docker and Ansible and Java and MongoDB and things like that. So like I said, I took a deep dive in around 2010 into JavaScript. I found it really fun to use and expressive, and share a little bit about framework fatigue. So here's a handful of popular frameworks. If you don't see your favorite framework up here, let me know so that I can include it in future iterations of this talk. But it's daunting, right? There's a lot of them. It's hard to figure out what's what, and it seems like a new one drops every day. It seems almost like these frameworks are going under faster than the startups that use them. So what do? Well, this one looks pretty cool, right? Vanilla.js, everybody's using it. Microsoft, Google, Yahoo. Right? The sad reality is that there's probably a lot of people coming to this for the first time that look at something like this and think it's legit, right? And it is. Vanilla JavaScript is a legit thing, but it's not a framework. Well, you may suffer from framework fatigue. Let's talk about some symptoms of framework fatigue. Confusion. So here's a bunch of concepts that are in popular frameworks. One-way reactive data flow, right? This is probably the most important contribution that React has brought to the table. Everyone talks about the virtual DOM and the speed, but the real contribution, I think, is popularizing this idea. Two-way data binding, which is popular in a lot of different frameworks. Not necessarily good. It's hard to reason about when your state's being manipulated all over an application, but it's got a great gee whiz factor up front. Micro frameworks, virtual DOM, extensible HTML, decoupled event-driven architecture, and the various flavors of client-side MVC. It turns out these all actually mean something. These are all important paradigms that these frameworks embrace. But it gets confusing. It gets really hard to keep up with these things and to differentiate them, and especially for newcomers. Ambivalence. Another framework, really? I mean, do we really have to go through this again? But mine's the right framework. Who cares about your framework? My framework does the job. Well, there's a bunch of frameworks from 1990s Java that still do the job, but do we still need to keep them? And do I even need a framework? And this actually becomes a valid question, especially now in the context of ECMAScript 2015. There's some language level enhancements that start to eat into some of the utilities and things like that that we have historically depended on frameworks and libraries for. Skepticism. So here's some claims that I just kind of scraped off the front page of some popular frameworks, some of which may or may not be true. But it's important to have some healthy skepticism going into it. It's important to understand that just because your friend who's developing with the right framework tells you that it's this super spectacular, magic, auto-magical thing, doesn't mean it's the case, right? And it is important to approach these things with a healthy degree of skepticism, right? Let yourself absorb some knowledge, let yourself try these things out, and see if these claims are actually true. Reduce capacity for hype and marketing lingo. I'm cured, make it stop. So here again, these are scraped right off the front page of a bunch of popular libraries and frameworks. They sound amazing. You know, I want to use half of these. I've used a couple of them. But are they true? Is any of this true? So we've seen what the symptoms look like. Let's talk about treatment. First treatment I have is to go native. And what I mean by that is that all things being equal, all other considerations taken into account, you should favor the built-ins, the standard library that JavaScript provides, over their equivalents in frameworks and libraries. So some of these are array methods, array for each. And there's a raging debate, and I have it with some of my developers on my teams, who just automatically reach for Lodash or underscore when they want to do array manipulation, particularly for each. And the arguments are one of two flavors usually. The first flavor is, well, it's faster. Lodash and underscore implementations are faster than native array.forEach. And that's true. Generally, the JS performance is a little slower. But my argument is that unless you're dealing with a really large data set, or performance is a critical path in your application, you're prematurely optimizing. If you're just grabbing this instantly and saying, it's faster, I don't think it's a valid argument. If you know ahead of time that performance is critical, then yeah, you can justify that. But in my next slide, I'll talk about why that might not be the case either. And the other argument for things like the for each method on Lodash or underscore is that it can handle both arrays and objects. It's kind of neat. You don't have to worry about it. It handles null checking too, right? It'll just ignore it if it's null. But I argue that with JavaScript being a weakly typed and dynamically typed language, there's a lot of uncertainty inherent, right? An object can be of any type that gets passed around. And if you can remove that uncertainty and be explicit about the intent of your code, if you're expecting an array, use an array method. If you're expecting an object, iterate over its keys. It makes the code easier to reason about and understand for other developers, which I think is more important. A lot of times, strong developers come to the table with a golden framework hammer or a golden library hammer. Everything starts looking like a nail, right? And before you know it, they've run rampant and they've got code that's no longer portable. The cost of switching between frameworks, especially opinionated frameworks that are very prescriptive, becomes expensive. So there's one guy that works on my team, super strong, senior developer. He comes from a background of server-side technologies, and he jumped into the front end a couple of years ago as an Angular dev. And he's a very strong Angular developer, but he didn't take the time ahead of time to sort of, get a solid foundation in JavaScript. And we had a really interesting, kind of learning experience for both of us. So one of the patterns that I use is you can sort of emulate proxies from ES6 using methods that dropped in ES5. So you write a factory. Factory takes an object and some interceptors, essentially, like the traps that you get in proxies. And you basically just do an object.getOwnProperty names, iterate over them, right? Use object-defined property, and use getters and setters. And then you can intercept those calls and do whatever you want with them. So I already had some of this in the code base. This guy came on board. I submitted a pull request, and we had this great learning moment, this aha moment for him, I think, where he looked at that and said, I didn't know you could do that in JavaScript. And it was a great opportunity for me to teach and for him to learn and for us to learn from one another. And ever since that time, I've always tried to steer him to, this is not a question of should you use frameworks or not. It's not a question of belittling their importance, and that's a raging debate. Some say that frameworks are not worth the cost that they impose. I'm not sure I agree with that. I think there's use cases. But this is more learning the fundamentals, getting a solid foundation, and understanding when is the appropriate time to use a framework method or a framework utility versus a native method or utility. So on objects, defined properties have been around since ES5. I run into a lot of developers, JS devs, that still aren't aware of some of these features that dropped in ES5. The ES5 was an incremental update to the language. I'm assuming you're all at a JavaScript conference. Everyone knows what ES5 is, right? Anyone not know what ES5 is? Okay. So it took a while for some of these features to get out into the wild. People were using polyfills because the browsers didn't support them. But 6 years later, there's still a lot of people that aren't aware that some of these features exist. And there's some really good reflective metaprogramming tools in there around object. Function.bind, when it dropped, a lot of people obviously didn't want to use polyfills, and they were already using underscore or Lodash. I think at this point in time, it's almost always better to use the native function.prototype.bind. There's some new string methods that dropped in ES6 versus using underscore.string for these things. We get starts with, includes, ends with. And then that last one, I have asterisks, tag template literals. Template literals in ES6 are not enough by themselves to create a templating engine. But when you combine them with the tag functions, all of a sudden it opens up a lot of possibilities. Now, I think probably some of the popular templating engines will start using tag template literals to implement their engines, and so that might be a moot point. Still worth learning, still worth using if you wanted to do like your own micro templating framework, something like that. So I mentioned performance. So this is one of the classic arguments for underscore or Lodash is going through an array. It's faster, right? And my argument is if performance really matters, go native anyway. This is probably as close as you're going to get to the most performant array iteration. Now, this assumes that order doesn't matter. It's going to go backwards through the array. But it still ought to be about the fastest implementation. And it's just plain JavaScript. All right, my next treatment is to go deep. A function within a function within a function. You're going to need a powerful sedative for that. So I recommend that you learn in depth everything that's already in ES5. ES5 is all still valid JavaScript. It doesn't go away because we have a new specification. And in fact, everything in ES 2015, or ES6, is a superset of ES5, which means all that code is still valid. Right? You still need to understand it. It won't suffice, particularly if you're new to JavaScript, just to learn ES6. There's the one versioning philosophy, which means the minute you add ES6 to an ES5 code base, it's all ES6. Right? So you do need to learn ES5. Like I said, ES5 dropped in 2009, and still a lot of JS devs today don't understand what's there or don't utilize what's there. And then a lot of the new syntax that's dropped in ES6, things like destructuring, and the rest and spread operators, things like that. A lot of them are actually just terse, concise syntax for things you can already do in ES5. So it really is important to understand what it is you can do with the language before you add these syntax sugars on top of it. Other things that are really important to learn in the existing ES5 code base. Prototypal inheritance. This is the one that trips most people up coming into JavaScript because it's so different from mainstream classical object orientation. But what about classes? JavaScript has classes now, right? Well, your classes are probably the most controversial drop in ES6. I'm still sort of on the fence, leaning towards negativity. On the positive side, you have this kind of friendlier syntax for classical OO devs, and it makes people that otherwise wouldn't look at the language possibly give it a first look. Also, a lot of frameworks and libraries have been sort of trying to glom on this OO classical syntax into JavaScript for years now. And if the community's doing it anyway, and it's fractured, standardizing it is a win, right? It makes tooling, automated tooling easier. On the flip side of that, the syntax, the syntactic sugar on top of prototypal inheritance and prototype chains is so different from the underlying semantics that it's kind of dangerous to those same OO devs that come in saying, this looks like, I know classes, right? And then they start using it and they go, this is not classes. Object.create is another feature that dropped in ES5. I think most people are familiar with it, but not a lot of people, not as many people as I would like to see actually use it. I think it's, in many ways, it's more superior than constructor-based prototype chains because you don't tie initiation and instantiation of your objects together. You can still use constructor functions with object.create. It's just a more flexible way of doing things. You should understand the difference between differential and concatenative inheritance. Differential being prototype chains, where an object differs from the members of its prototype chain, and concatenative inheritance, which is essentially mix-in, where you can have multiple inheritance. JavaScript being a multi-paradigm language, a dual paradigm language, has classical prototypal OO and functional programming. There's a lot of tenets to functional programming that aren't necessarily specific to JavaScript, but it supports quite a few of them. The most important is going to be first-class and higher-order functions. you should certainly understand, even if you're not aware that it's functional programming, you use lambdas all the time. Anyone that's used callbacks, anonymous functions, uses lambdas, right? We have functors like map, reduce, things like that. Pure functions are simply functions that have no side effects, right? JavaScript supports this, and these two paradigms are critically important to understanding what you can do with the language. In JavaScript, you can program entirely in a functional style. You can also program entirely in a procedural style. Right? You can also program entirely in a prototypal style, but more than likely, you're going to be programming in a hybrid of these. You should understand closures and variants of them, like immediately invoked function expressions, the module pattern. Type coercion, whether or not you leverage it, Kyle Simpson has a great lecture on using type coercion to your advantage, and he's a big proponent of it. Most people steer clear of it, but you should understand how it works. Type coercion, if you understand it, you won't get caught up in the pitfalls. You should understand lexical scope and hoisting. So in ES6, we get block scoping finally in JavaScript. But until then, all we've had is global or function level scope, lexical scope. You should understand equality and strict equality. And in ES6, we get super strict equality with object.is. Object.is is one of those odd little things. There's like 2 use cases for it. It's kind of weird how it made it through the spec like that. If you're programming in JavaScript, aside from the multi-threaded JavaScript project, and the name is escaping me right now, you're going to be running in a single event loop, right, in a single thread. So you need to understand the asynchronous environment in which you're working, and you should understand callbacks. Promises are a nice pattern on top of callbacks that abstract it away for us a little bit. And in ES6, with asynchronous generators, you can do even more abstraction. And in ES7, with the await and async keywords, we get even one more level of abstraction that starts to make asynchronous code look like synchronous code. It makes it a lot easier to reason about. But you should understand what's happening under the hood. Right? Just like if you're using classes, you should understand that the syntax is different from the semantics. You should understand how asynchrony works in a basic level, how the event loop works, how event handlers work. Then you're going to learn an abstraction on top of that that makes it easier perhaps to reason about and read about your code, but you'll have that firm understanding underneath of how things are working. You should absolutely understand function.call and function.apply. Bind as well. Call and apply are the really important ones, right? Because of context idiosyncrasy, we get to borrow behaviors from other objects using call and bind. And then you should understand what in the hell this is. I saw a guy on Twitter, and I'm going to I'm going to misattribute this quote. I saw a guy saying, every time I program in JavaScript, I just want to throw my hands up in the air and say, what the fuck is this shit? But I can never remember what this is. So once you've got a good basis in ES5, you should learn ES6 and beyond. ES6 is now the specification, so it should be safe to go ahead and start using it, assuming that browsers will catch up. We've entered a new world now where we don't really need to wait for browsers with these transpiler engines. We've had polyfills for a long time, and even with transpilers, for some features you need to use polyfills. But you should get a good grasp of ES6 now. ES 2016 has some great stuff coming as well. And it kind of falls into 3 major categories. We get new syntax introduced into the language. Things like let, const, the rest and spread operators, destructuring, and arrow functions. And pretty much without exception, these new syntax are, as I mentioned earlier, just new ways of expressing existing functionality. They don't really add anything functionally to the language. They just give you the ability to write less boilerplate to achieve the same ends. We get an enhanced standard library. We get some really important enhancements to object, and especially array. String and regex are also useful. Most of the additions to math and number are aimed at transpiled to JS systems like Emscripten. There's a lot of stuff that's kind of geared specifically for C and C++ type development. And then we get some entirely new features in ES6. And this is where it gets interesting, right? I think that generators are probably one of the most important additions to the language. The possibilities with generators really kind of open up some pretty amazing things. They start to bring the language on par with some of the other serious languages out there. JavaScript gets a bad rap. Some of it is justified. Some of it comes from the rapid nature in which it was developed. Some of it is odd design choices. But it's also been incredibly anemic in terms of its standard library and the feature set that it provides. Now, that's both a blessing and a curse. On the one hand, it's super lightweight, right? In some ways, JavaScript has fulfilled that promise of write once, run anywhere that Java failed to deliver on. But at the same time, we've had to rely on this ecosystem of libraries, frameworks, and things like that to provide us with some of the basic functionality that we would get out of the box with other languages. And so these things that are being dropped in ES6, it's the first really major overhaul of the language since 1999. We got ES5 in 2009, but it was a compromise over a failed ES4. It was originally codenamed ES Harmony, it was ES6, right? And it was because these factions that split over what ES4 should be, they finally came to the table and said, okay, we'll compromise. We'll do a utility release, and that was ES5. But it wasn't really a major update. The last major drop was ES3. And so ES6 is a major leap forward for the language, and it represents kind of a sea change, I think, in what we can do with it. And there's my shameless plug. This is a 3-part series I did for the Santa Barbara JavaScript meetup. Please go check them out. They're GitHub Reveal.js presentations. So my last treatment here, second to last treatment, is to use the source. Surprisingly, a lot of popular JavaScript frameworks are written in JavaScript, right? There are increasingly those that aren't, right? Elm is the popular new language out there. I haven't had a chance to play with it myself, but one of the guys at the meetup did a presentation on it. I plan on digging deep into it. There's various other transpiled JS languages, but most of the popular ones are actually written in JS. So, if you're struggling to understand how these things are implemented, or particularly if you're new to something, read the source, right? Because you're going to see exactly, and start with the things that you're actually using, right? Don't just try and read the source from top to bottom. That's like going to the spec for ECMAScript and reading it top to bottom. It doesn't make a very good novel to go to bed by, right? But there's useful information in there. And if you go and you look for the things that you're trying to find, it's spelled out in black and white. And the same thing is true for the source code in a lot of these frameworks and libraries that you use. Start with methods that you use on a regular basis, like for each, right? And see how they've implemented it. And it turns out that it's usually not that hard to understand. That doesn't zoom very well. This is from Ember. This is their for each. And basically what you can see about 2/3 of the way down, it's just a for loop, right? It's pretty simple, procedural, easy to understand stuff. There's from Angular. Same thing. They do some checking to see what it is that and again, this is one of the arguments for using a framework or library method, is that you can pass it an object or an array, and it will iterate through either ordinals in the array or properties on the object. But when it comes down to it, once it's done with the checking, it's just a simple for loop, right? It's basic JavaScript. And then here's Lodash. Right? Here's Lodash's implementation of array each. Lodash just splits it into 2 separate functions. It checks if it's an array. If it's an array, it does array each. If it's an object, it does object each. But this looks kind of similar to my little native while loop that I had earlier, right? So it can be extremely valuable as you're learning these things to look at what other people have done and see how it's implemented. Some good resources there. These are a little older, but I still think they're really valuable. John Ressig recently just published the original jQuery source, annotated. Jeremy Ashkenaz posted underscore and backbone, and they're among the few developers that have taken the time to go out there and walk you through in a narrative style how the code was written. So not only can you see the actual source code, you can see the developer's thought process. You can get an idea of why they did things the way they did that can help inform your understanding of it. And then that last one is a video by Paul Irish from 2010, where he talks about it from our side as a dev, going through and reading through the source code and the important lessons that he learned from it. The last treatment I have is to learn what is and what isn't JavaScript. This picture is often used to belittle JavaScript, right? The good parts versus the definitive guide. But what this picture doesn't tell you is that the definitive guide includes a whole bunch of stuff that isn't JavaScript. Right? It's written mostly from the perspective, though it's been updated recently, mostly from the perspective of a browser JavaScript developer. And so it includes all the tools that you need to get up to speed writing JavaScript in the browser. It covers the DOM. It covers cascading style sheets. It covers the XML HTTP request object, and a variety of other ancillary technologies that are provided by the host environment. They're not JavaScript, right? So even though Doug Crockford's book might be even more narrowly focused, it's still, you could cut out at least 2/3 of that other book to cover just JavaScript. So it's important to understand the difference between the language and the environment that it's running in, right? And that environment now isn't just browsers. It's on the server. It's in a variety of popular database engines. It's now a first-class citizen for operating system automation. It was the first language to be allowed for iOS development after Objective-C. And so each of those environments provides some host-specific APIs, right? Some of those APIs are not necessarily host-specific, like in the browser, you have the XML HTTP request object. It's not browser-specific, it's a specification. But nevertheless, that's an API that's provided to you in a JavaScript consumable format, but it is not JavaScript. There's also complementary technologies like cascading style sheets. And my recommendation is get a solid foundation, go deep into the language first. Understand what JavaScript is, what it can do, what its limitations are, and then do the same with the supporting technologies. Go look at DOM, take a deep dive into the DOM API, see how the different browsers implement it, what its shortcomings are, and there are plenty, limitations, etc. Get familiar with all of that, and then start to coalesce that knowledge into a whole, right? And lastly, this is not JavaScript specific, but this is kind of more an approach to how not to get swamped by this constant barrage of frameworks out there, and that's to learn how to learn. Change is the only constant. You know, even the right framework, the days are numbered, and that means React too. React is amazing, but even its days are numbered, right? These frameworks will continue to drop and evolve, and or, you know, one of the emerging trends is micro frameworks, right? And micro libraries, and putting together your own framework, which comes with its own advantages and disadvantages. On the one hand, you can curate your own set of specific functionality that each of these micro frameworks or libraries provide. On the flip side, you're then in the wilds wondering how do you orchestrate all these things together, right? And a framework, depending on how prescriptive it is, will opinionate that for you. You cannot know everything about everything, no matter how smart you think you are. I also argue you cannot know everything about anything. Right? If you try to be an expert these days on one particular technology, unless it's your own open source project or your employer is funding it, you will not be able to be an expert before it changes. Things just change too quickly, right? My recommendation is to learn enough to be productive, learn enough to get by, and then improve by immersion. If you end up using it, you will absorb more knowledge, right? Work with other users, other developers on your team, and you will gain the knowledge you need to improve your understanding of that particular domain. And then this is one I'm struggling with, which is developing a strategy for focused knowledge gathering. I tend to be a hoarder. I save links, I save podcasts, I save videos, and they all just go into this bin, and I never actually get around to watching them or reading them or listening to them. And then I go back to try and find them, you know, a year later or 6 months later, and I wade through all these bookmarks in my browser or this huge file folder full of videos, and I'm trying to develop strategies for being smarter about it, being more selective about what I save, and using tools. I started using Pocket recently, which helps me to search for things that I've saved and things like that. But it's important that you don't, A, hoard knowledge, and B, that you actually use things, right? You see something great on a topic you're working on, it's important to get that information in a way that's digestible. So some side effects, once you've gotten the treatments out of the way. You may acquire language level skills. You may have increased confidence about your ability to use JavaScript and better problem solving ability in your next JavaScript project. And most importantly, you may end up knowing what this is. Now, lastly, occasionally JavaScript users have reported a desire to write their own frameworks or abandon frameworks altogether, although this is rare. And that's all I got. Thanks, guys.